Hey, this is Mr. Hansen. In the last video, we talked a little bit about the addition rule for compound uh, probabilities, and this time we're going to talk about rule for the multiplication rule. So let's look at the diagram here. First of all, we have two questions maybe that we'd have in a survey. Do you like rock and roll? And the answer would be yes or no. And do you like country music? And the answer would be yes or no. And in this case, so we have, let's just take a look at it. The probability of liking rock and roll is 0.4 plus 0.2 or 0.6. Probability of liking country is 0.2 plus 0.3 or 0.5, 50%. The probability of liking rock and roll and country is 20%. So said yes to both, and then the probability of liking neither is 10%. So let's also put this in a frequency table so you can see it that way too. So if you liked rock and roll and country, it was 20%. If you just liked rock and roll, it was 40%. So 60% of the people in all surveyed liked rock and roll. And country and rock and roll, 20% again. And if you just like country, 30%. And if you liked neither, 10%. So let's finish the marginal frequencies here. We've got 50% here for country, and then we've got 40% here. Didn't like rock and roll, and we got 50% didn't like country, and then 100% here. Okay, so let's see what we've got going on. So first of all, if we wanted to, just a review here, if we wanted to find the chance of liking either rock and roll or country, we would add together 0.4 plus 0.2 plus 0.3, or we could say 0.6 plus 0.5 minus 0.2. We'd add those together and then subtract out the 0.2 because it was listed twice, and you'd have the possibility of liking both rock and roll and country. But we're going to look at something different this time. We're going to kind of focus on this piece right here in the center here. So that's instead of liking either rock and roll or country, which is kind of the whole thing, two circles, we're saying likes both rock and roll and country. And there's a chance that liking country is going to influence whether or not you like rock and roll, and so that's kind of important. So that's kind of where we're headed with this. Let's go ahead and start with the probability of rock and roll here on the left. We've got 0.4 plus the 0.2, so 60% chance of liking rock and roll. And then we're going to talk about the probability of liking rock and roll. So rock and roll, that's taking this one here out of that one, 60% chance. Now we're going to take the probability of liking rock and roll given that you liked country music. So this time we're talking about out of all the people who like country, so we're talking about this circle right here, what percentage liked rock and roll. So everyone who liked country is, out of all the people who liked country, that's 0.2 plus 0.3, that's 0.5. And then we've got 2 people liked rock and roll. So I actually have it written wrong here. So it's just 2 out of 5, which is 40%. So if you like country, chances are less likely that you'll like rock and roll. Kind of an interesting thought there. Okay, so we're saying that this event, or these two events, are dependent. So liking rock and roll kind of depends on whether you like country or not. If you like country, you'll be less likely to like rock and roll. So if they were exactly alike, we'd call them independent events. So when probability of rock and roll is equal to probability of rock and roll given country, then they are independent events, meaning one does not have any bearing on the other. As it is, they are dependent events, meaning that the probability of liking rock and roll given you like country is a little bit less than the probability of just liking rock and roll. So people who like country don't like rock and roll as much. Okay, so let's talk about how we got this here. Remember we said the country, the whole thing on country, given that you like country, and then this piece right here out of, so 0.2 over 5. So let's just kind of label what we're doing there. So we've got probability of rock and roll and undo that. Probability of rock and roll and country is the 0.2 right there. And out of the people who like country, and that's 0.2 plus 0.3, that's 0.5 there. And that gives us our 0.4. So what I'm saying is that this right here is just this right here. That's how we find it. So I've written this down here. So that and from this equation, we can actually get the chance of one happening, or of both happening right here. We can get that alone by timesing by the bottom here. So I'm going to times by the probability of country music. So you end up with probability of rock and roll intersect country music, so they like both of them, equals the probability of country music times the probability of rock and roll given whatever conditional country music had. So this is kind of the big idea right here. It's called the multiplication rule, and it gets us that right there, that 0.2. So we can say, let's just plug the numbers in. So probability of country is 0.5, and probability of rock and roll given you like country is 0.4. Let's see. Yeah, 2 out of 5, that's 40%, 0.4. And then if we multiply 0.5 by 0.4, we end up with 0.2 right there. And so that's how we kind of get that intersection there. And we can look at this on the frequency table too. So here's our 0.2 right here, and that equals a probability of country, 0.5 right here, times our probability of rock and roll given country, and that's 0.2 over 0.5, that's 0.4 there. So it's a little bit harder to see on this, but this is kind of the multiplication rule. And I want to work through, I want to talk about dependent and independent events with you, and then work through just a couple of multiplication rule ideas. So let's switch over here. If probability of A equals probability of A given B, then the events are independent. Means they have no bearing on each other. And here's an example. Let's say you flip a coin twice. So the first flip is the probability of A, and the chance of getting, and you want to know the chance of getting 2 heads, okay? So you can kind of think of your sample space: head, 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 tail, 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 head. So the chance of getting 2 heads looks like it's going to be a 1 in 4. So, and if you think about this, it's just going to be, this is flipping a coin twice. This is called an independent event because the second flip is not going to be based at all on the first flip. Whether you get a head or a tail on the first flip is not going to determine anything about whether you get a head or tail on the second flip. So these these events are independent of each other. And if that's the case, all we have to do is multiply probability of A by probability of B. So the probability of A is 0.5, and the probability of B is 0.5. And a half times a half is a fourth, and there's your answer right there. It's a 1/4 chance of getting 2 heads. So that's an example of independent events. One event does not have any bearing. The first event doesn't have any bearing on the second event. Let's take a look at dependent events. So in this case, you have a bag of marbles. And let's say there's 10 marbles, and 3 of them are red, and 7 of them are yellow. Oh, 7 of them are yellow. Okay, so you pull a marble out of the bag. What's the chance of getting a red? Well, it's 3 in 10. 3 in 10 right there. So, but now you don't put the marble back in, no replacement. So the second event depends on the first event. So this time, instead of probability times probability A times probability B, we're going to have probability of A times probability of B given A. So a conditional probability here. Okay. So let's see how that changes. So we've got 3 out of 10, and now probability of B, we pull out a second marble, given that we pulled out the first marble already. So now there's only 9 marbles left, and there's only 2 of them that are red if we're trying to pick 2 reds in a row. So instead of 3 out of 10 times 3 out of 10, it's 3 out of 10 times 2 out of 9. And we can multiply that together, and we get 3 times 2, that's 6, and 10 times 9 is out of 90. And if we can simplify that a little bit, or we can just put in the computer, we can put in a decimal. It's probably the easiest way. Put in a decimal in the computer, and I'm doing that right now. 6 divided by 90. Oh, let's try it again. 6 divided by 90 equals 6.6%. So about 6 in 100 chance of picking 2 reds in a row there. And again, this formula was based on the fact that the second event depended on the first event. So probability of A happening times probability of B happening, given that A already happened. In contrast, over here, we just have probability of A times probability of B. These are dependent events. Let's call that good for right now. Hopefully that made a little bit of sense to you. Please rewatch if necessary. Thank you for listening in. And this is Mr. Hansen signing out. Have a nice day.